to our climate change discussion. We're the Climate Change Brothers. We talk about agriculture, engineering, and energy. So today we have a great topic. It's on life cycle analysis.
Life cycle assessment. Well, they're both kind of the same.
Yeah, well, you try to correct me, splitting hairs.
I'm always correcting you, yeah.
Yeah. Of course, the brothers do. Okay.
Yeah.
The best way to compare the GHG emissions among renewable and non-renewable energy sources is to do a life cycle assessment study on them.
So, you know, when people talk about, renewable energies are so much better than, the non-renewables and stuff, well, you have to consider everything. And that's what life cycle assessment is supposed to do, right? Is consider the whole lifetime of the energy production of things. A life cycle assessment can talk about the greenhouse gases it produce over its lifetime, right? So that's something that as far as climate change is concerned, what people are a lot talk about, right?
Yeah, that's kind of where most of the emphasis is, but is like there's a lot of environmental impacts that have to do with pollution. You have water and land and soil that can be affected. So it's not just greenhouse gases, but that's where the emphasis seems to be placed.
Right. Most people talk about the greenhouse gas problem.
Yeah.
So what's the definition of life cycle analysis? What would you actually, if you had to sum it up, what would you say?
If I had to sum it up, well, I'll just give you the definition of what it is. It's the systematic analysis of the potential environmental or other impacts associated with their products throughout all of their life cycle stages of procurement, production, use, and end of life.
So
production.
There's four stages. They kind of group it into that. So the four to sum up the four are basically like procurement or production, processing, usage, and then decommissioning, something like that, or end of life, you want to.
Life cycle assessment shows that coal plants emit twice the amount of GHGs compared to natural gas power plants.
If we look at the energy sector, let's talk about that a little bit. The energy sector, right? To produce energy, we're talking about there's an impact life cycle assessment on that for greenhouse gas emissions specifically.
Mm-hmm.
Okay, so we'll go to the example of, for instance, when we produce coal, we had a lot of coal production, power producing plants, right? We changed those over mainly to natural gas. We have some coal plants that operate, but not very many anymore. But they mainly have been replaced by natural gas. So if you look at their life cycle assessment, over the lifetime of a natural gas production, power production facility, over its lifetime it produces about half of the greenhouse gases as does a coal plant. And so,
interesting, yeah,
which is interesting. That's one of the reasons why over the last couple of decades we've been able to in the United States we've been able to decrease our total greenhouse gases emission steadily over those years because we've been doing that.
And I'll tell you, what he's talking about is during 2000. It's kind of started around 2010, but we used to have about 500 coal plants. We've decreased that number by over half in just a little over a 10-year period. So we're decommissioning a lot of coal plants.
In order to compare the GHG emissions of all types of power, it is necessary to normalize the results to the amount of GHG per kilowatt hour of electricity.
In life cycle, sometimes as far as energy production goes, it's hard to compare a wind generator or a nuke plant and a natural gas power plant to each other because they have different factors, right? And so, but they all produce energy, and so they normalize it in some way, shape, or form, into what they call grams of CO2 per kilowatt hour. So that each of them has a number associated with their life cycle analysis for this specific thing for climate change impact assessments. Okay, so for instance, a natural gas power plant produces, CO2 emissions while it's powering, but also has a CO2 upfront cost when they're making the plant, right? Because a lot of cost and energy just to put the plant up, right? So, but then they factor over its lifetime of the power plant plus all the greenhouse gas it's emitting. They figure per kilowatt hour of production, energy production, how many grams of CO2 does that average over its lifetime? Okay, so that's sort of a nutshell how they compare apples to oranges. So, for instance, a natural gas power plant has around 500 grams of CO2 per kilowatt hour over its lifetime. Okay, Whereas a coal production plant is just like 1,000 or more of grams of CO2 per kilowatt hour, which is quite a bit. Okay, probably the most that you have for any sort of energy production type of thing is coal. So 1,000, that's quite a bit.
For solar PV panels, some GHGs are produced when manufacturing and disposing of them. They are about half the lifetime emissions of a natural gas power plant.
So because it's like, well, how do I, you have a solar panel and it's not producing any greenhouse gases. Why are you dinging on solar panels? Well, because solar panels have a cost in greenhouse emissions when they're produced, and of course when they're disposed of. So, and when they're transported, etc. So, when you're talking about solar panels, okay, because they're not producing much at all in greenhouse gases while they're sitting there producing power, they have a great average over their lifespan of, like, say, over 20 years. So that goes down to now a couple hundred, maybe 200 grams of CO2 per kilowatt hour, which is still pretty good. That's maybe half of what a
natural gas plant
does. So that's good. So now we're reducing it in half again if we use solar panels. So that's not bad. However, they do another thing. So the fourth category being disposal of the panel. A lot of these companies assume that you're recycling every component in the solar panel, the glass, the metal frame, and all of the wafers in there that you can chop up and then recycle the materials in there. And that's an expensive yet complicated process.
I think only 5% actually gets recycled.
So that's a little
around 5%
as well.
actually gets recycled. So
that's a problem, I think. But still, even if you add a little more, so let's say they may be pushing more towards the 250 to 300. Realistically, those grams of CO2 per kilowatt hour. That's still less than a natural gas power production plant. So,
in order to accommodate a huge influx of solar and wind power, as well as a high number of electric vehicles, it should be incumbent of us to do life cycle assessment studies of the electrical grid as it pertains to these subjects.
in some of the past videos, we brought up the ideas that if you have all these solar farms that are around the country, or if you're increasing the number of electric vehicles, will our electric grid be able to support all that? I mean, that's something we really don't know offhand. I don't think anyone really know. I mean, we shouldn't do so much of that the electric grid can't take it. So what kind of changes would we have to make? What would be involved with this? I mean, part of this could be solved by doing these life cycle assessments that are non-biased. I mean, also, obviously you want to do that, but you want to do it in the right way. So I think that's something that California really needs right now.
Yeah.
Actually, is I think because of their policies, I think they need some kind of life cycle assessment, a deep overhaul of their electric grid for life cycle assessment if they're going to do no electric cars by.
Yeah, I mean,
and all these solar. You know what I'm talking about?
Yeah, right? You're definitely right. I mean, they need a holistic approach to look at it overall and probably come up with a long-term plan. They can't just go, hey, let's go all solar. Hey, let's go all. And it's not like what happened. They had to, when they got real hot there recently, they had to say, well, let's not charge our electric vehicles at night because we don't have enough power to support the electricity, right? So if you're going to increase the number of electric cars over the next 10 years, you're talking about a lot of capacity you're going to have. You're going to have to come up with a comprehensive solution that may include some non-renewable energies that supplement some of these powers.
In a future video, we may discuss the life cycle assessment by comparing a fuel-efficient gasoline car to an electric vehicle.
Or that we did also maybe in the future we might want to talk about a life cycle assessment comparing electric cars to the environmental impacts of electric cars to gasoline efficient cars, because you brought up the point that we honestly think that you get a better environmental impact with gasoline cars than you would with an electric car.
High efficiency gas car.
Yeah, a high efficiency gas car
we'll look
than an electric car.
And also, there's when you talk about financial costs of these things, you got to factor that in as well, because that's a reality for a lot of people. And there's people that can't afford certain things, right? So you can't just go out and buy an electric car, right? So
to summarize, coal power plants produce around 1,000 grams of carbon dioxide equivalents per kilowatt hour, whereas natural gas plants are about half of that, or about 500 grams, and solar farms are even half of that, which is about 250 grams per carbon dioxide per kilowatt hour. In addition, comprehensive life cycle assessment studies should be performed on how the electric grid will be able to handle a large volume of electric cars as well as solar and wind power. In other words, what measures need to be taken to upgrade and change the grid for these particular changes.
All right. So, well, until next time, we're the Climate Change Brothers and talking about agriculture and energy and engineering and all things
Related to climate change.
related to climate change. So, until next time, we thank you and we're out.